algorithm, and then we can predict the word, we can predict the character, or even we can predict the entire statement as well. So that is a text classification. Image classification, you can classify the image. For example, if suppose you are using the security camera, periodically you are capturing the images, and then you are analyzing these images on the basis of the security concern. So for example, if suppose there is an image where where a cat or the squirrel is going on, it is not a threat to your security system. But if suppose there is one human being having gun in the hand, in that case you can say that yes, there is a problem with the security concern. So you can classify the image into different types. This is one only example I have said you. So you can classify the image. In bioinformatics, you can have a protein classification. Handwriting recognition is something which is very important. See, if suppose you find as well, there is very less possibility that both the signs of yours will be having the same type. So if suppose I am using the pixel by pixel mapping, or if suppose I am using the OCR, I am very much sure that I'm going to fail. And that is the reason in the banking system, still this handwriting or the sign matching is done manually only. We are not using any computerized system. In fact, a few people have signed so complicated that even bank people are not able to recognize that whether they are same or the different. So in such situation as well, what you can do, you can use the support vector machine to classify whether the sign is right or not, whether the character is appropriate there or not. Now, from all these examples, what do you think, whether SVM will be regression or the classification, what it can be? Anyone would like to try?
The classification.
Bilkul, right, Shell? It is classification only, because see, you already know that whenever I am teaching, I am trying to relate the things with our earlier lectures, and the same thing we will do here. So you know that in the regression, you are always going to get some value, some fixed value, that is a predicted value. But as far as your classification is concerned, you are classifying your observation in the particular class. So for example, if I look at the face detection, then whether my system is able to detect the face or not able to detect the face. So there are only two classes, yes and no. Similarly, in the text classification, if suppose it is for the character, then it is able to whether detect the character and then classify according to the alphabet, capital A, capital B, small b, or not. So basically, it's a classification only. SVM is used for the classification largely. There is an variant of the SVM called SVR, support vector regression, which is used for the regression analysis, but SVM largely it is used for the classification. So as Shailev rightly said, it is an classification type algorithm. You can apply it on the classification type problem. It is a supervised machine learning algorithm. Now, in the if you can recall our yesterday's lecture, what was supervised machine learning algorithm? In the supervised machine learning algorithm, whenever you are training your machine, you are giving both input as well as output. So for example, if I talk about the face detection, there are 50 students in the class. I have to give at least 100 photographs of each of the students. So in total, there will be around 5,000 photographs. My machine will be trained with these 5,000 photographs, labeled each photograph. For example, there's a photograph of the Darpan. So system already knows that this is the photograph of the Darpan. If suppose there is a photograph of the Kavya, system already knows that this is a photograph of the Kavya. So this is supervised machine learning algorithm. Whenever you are training the model, you are supposed to give both input as well as the output, actual output. Later on, whenever you will give any unknown data, the system will try to predict whether the input, whether output, predicted output is matching with any of the input or any of the output or not. So this is a supervised machine learning algorithm used to solve classification type problem. Now this is known as the large margin classifier. We will understand that uh, in the next few slides, that why it is known as a large margin classifier. Now, the name itself suggests that you need to increase the margin. So, something which increases the margin is known as the large margin classifier, and SVM is the large margin classifier. We'll see that, don't worry. The goal of SVM is to find the optimal hyperplane that maximally separate the two classes. And even you can have a multi-class support as well. So let us understand. So if suppose um, you have this two data. So x-axis contains the x, that is the input, y-axis contains your output, that is a y. Now whenever you will plot this x against the y, uh, you are getting observations like this. For triangle, you assume that it is one set of the data. For example, अगर हम बात करें ऑथेंटिकेटेड ट्रांजैक्शन एंड फ्रॉडन ट्रांजैक्शन, तो आप ऐसा मान के चलो कि जो रेड वाले हैं दे आर द फ्रॉडन ट्रांजैक्शन एंड ब्लू वाले हैं दे आर द ऑथेंटिकेटेड ट्रांजैक्शन. सो फॉर एनी पर्टिकुलर एक्स, अगर मैं आपको कोई भी एक्स की वैल्यू दूं, तो वो एक्स की वैल्यू के बेस पे यू विल बी एबल टू फाइंड आउट दैट वेदर दिस इज अ authenticated transaction or the fraudulent transaction. So with X, with input, you can always find out the output, which is the Y. Now, this is known as the margin classifier because what we are going to do, we are going to draw one line from here. हम यहाँ पे क्या करने वाले हैं, एक line draw करने वाले हैं. So if suppose I have a some value called X, मेरी कोई X value है, और वो x के हिसाब से suppose I want to predict the value of the y, so I will train my model in such a way that whatever x are on bottom of the line, they will be the fraudulent transaction, and whatever transactions they are on the top of the line, they are the your regular or the authenticated transaction. So SVM, the main role of the SVM is to find this line. SVM का काम है इस लाइन को फाइंड आउट करना. नाउ ये लाइन फाइंड आउट करना बहुत डिफिकल्ट है. इट इज नॉट दैट मच इजी जॉब. सो वी विल सी कि ये व्हाई टू फाइंड आउट दिस लाइन इज सो डिफिकल्ट. But all of you understood na कि what is support vector machine? We need to find this hyperplane. Now we are using a new terminology called the hyperplane. So what is hyperplane? In the n dimensional space, for example, मेरा डेटा 2 डायमेंशनल स्पेस का है, तो मेरी जो हाइपर प्लेन होगी दैट विल बी n-1, दैट इज द 1 डायमेंशनल. नो इसको एक और लेवल नीचे जाके हम लोग देखते हैं. फॉर एग्जांपल, इफ सपोज यू हैव अ लाइन, व्हाट इज द डायमेंशन ऑफ द लाइन? किसी भी लाइन का डायमेंशन क्या होता है?
वन डायमेंशन.
Line is 1 dimension. Okay. So what is the equation of the line? Y is equal to mx plus c, right? So where there is a y, there is a x. अब बोलो कितने डायमेंशन हुए?
2.
Yeah, line is always 2 dimension. Now if I ask you कि I want to divide this line into 2 parts, मुझे 2 पार्ट में डिवाइड करना है, तो मुझे क्या करना पड़ेगा? आई हैव टू सिलेक्ट एनी पॉइंट ऑन द लाइन. मुझे लाइन के ऊपर कोई भी पॉइंट एक सिलेक्ट करना पड़ेगा. अब ये पॉइंट का डायमेंशन क्या है? कैन एनीवन टेल मी दैट व्हाट विल बी डायमेंशन ऑफ पॉइंट? Point is always 1 dimension. So to separate a 2-dimension line, we are using 1 dimension point. Similarly, to separate this 2-dimensional space, we are using a line which is a 1 dimension. अगर इसी तरह, for example, there is a 3 dimension. So for example, you can see here कि मेरा R3 is a 3 dimension plane. अगर मुझे इसको 2 पार्ट में सेपरेट करना होगा तो मुझे क्या ड्रॉ करना पड़ेगा? मुझे प्लेन ड्रॉ करना पड़ेगा, और वो प्लेन का डायमेंशन क्या होगा? it will be the two dimension. And that is the reason कि whenever you want to divide your space, that this hyperplane will be always n minus one. तो अगर आपका जो डेटा है वो your 1D data है, sorry 2D data है, तो in that case you can always use the line as the hyperplane. अगर 3D data है तो you can always use the plane as the hyperplane. Rule is always fixed. If suppose you have a data which is 10 dimension, तो आपका hyperplane क्या हो जाएगा 9 dimension. It will always be n minus 1. The entire idea behind support vector machine is to identify the appropriate hyperplane. You need to find out this hyperplane in the best possible way. So this is the idea behind the support vector machine. Now I have used the word appropriate hyperplane. So what is this appropriate hyperplane? If suppose I have a data like this, on the x-axis I have some value, y-axis I have some value. So if you notice here, there are blue points which are concentrated here. There are red rectangles which are concentrated here. And these are the two different ways. These are the two different ways to divide this data. जो टू डायमेंशनल डेटा है, इसको डिवाइड करने के ये दो तरीके हैं. Which are the two ways? One is a line A, another is the line B. Now, can anyone tell me which of the way is good, whether line A is good or the line B is good?
Line B.
Line B. Why line B is good?
So nearer to the one of the data points.
Okay. Now the problem with this line B is that.
So shouldn't it be line A?
So let us try to understand both the points, line A or line B. So for example, are you able to see my mouse, Darpan?
Yes, sir.
Okay. Now if suppose this is a point, अगर यहाँ पे कोई एक ऑब्जर्वेशन आता है, so that observation will be where? ये ऑब्जर्वेशन आपका लीगल होना चाहिए कि इलीगल होना चाहिए? Just above the line B and below the line A, somewhere here in the corner. Wait, let me, if I can put some point here, pointer. Okay. Okay. So if suppose there is one observation here. Now this observation will whether it will be the valid observation, whether it should be in the blue category or the red category. Darpan, according to Darpan, it has to be on the red category. According to the Kavya, it has to be in the blue category. Now, logically, if you see, this observation is much closer to the entire this channel. So this observation is much closer to all this than this observation. So ideally, whatever the observation is there, it has to be considered as the blue dot only. So the thing is that we are selecting here A. Why we are selecting here A? Because here the margin between both the cluster is maximum. And believe me, whenever you are going to use the SVM, our objective would be to identify the hyperplane which maximize the margin. इसीलिए हम इसको बोलते हैं large margin classifier. Why we are calling it as a large margin classifier? Because in the large margin classifier, we have to find out the hyperplane which increases, which maximize this margin. ये जिस margin की हम बात कर रहे हैं, this is margin. So here the margin is maximum in comparison to this. So we have to select this particular hyperplane. So whenever you will run any SVM based algorithm, your objective would be to identify the hyperplane. In our case, it is line. You have to identify the hyperplane which maximize this margin, and that is a reason this is known as the large margin classifier. Kavya, Darpan?
Got it.
Yes, sir.
Okay. let me, okay. So, so I hope that now all of you are very much aware about what is the basic idea behind the support vector machine. Now, let us talk about which are the different type of SVM. Now, one is a linear SVM, another is a non-linear SVM. And this example we have seen, it is a linear SVM. Both these examples are again linear SVM, and this is also the linear SVM. And what will be the non-linear SVM? So in the linear SVM, there should be a line, there should be the plane which should be able to divide this data into two halves. So आपका जो division होगा, that has to be the linear in nature. If it is not linear in nature, then it will be called a non-linear. Now let us see the example of non-linear. So this is the example of linear SVM, and here you can see that I have a set of the data somewhere here. I have another set of the data here, and I have selected this line because this line creates a maximum margin. Now see this जो आपका margin वाला point है. So what is the maximum margin? The length from this point to this point is known as the maximum margin. Now, ये आप draw कैसे करोगे? You will be selecting this point. This point is a last point which is touching here, and these 2 points are the last points which are touching this particular margin. And these points are known as the support vector. ये आपके maximum margin को support कर रहे हैं, and that is the reason they are known as, these points are known as the support vector. So entire idea behind the SVM is to identify the support vectors in such a way that it maximize the margin. आपको वो support vector find out करने हैं जो आपके margin को maximize करें. And this is the example of the linear SVM. Now, अगर आपका ऑब्जर्वेशन ऐसे हैं, तो आप देखो यहाँ पे, ये आपकी जो नीचे वाला पार्ट है, दिस इज द रेड डॉट, ऊपर वाला ब्लू ट्रायंगल. इज देयर एनी वे कि आप इसमें लीनियर ड्रॉ कर सको? कोई तरीका है लीनियर ड्रॉ करने का? आई कैन नॉट सी, और कोई तरीका है ही नहीं. एंड दैट इज द रीजन कि यू कैन नॉट सिंपली ड्रॉ हियर लाइन, you have to draw here polynomial. आपको क्या करना पड़ेगा? यहाँ पे polynomial draw करना पड़ेगा which divide your data into two parts, and this is the example of the non-linear. And as the name suggests, linear means line, non-linear means anything else like your polynomial, your circle, even circle भी आएगा, देखते हैं हम लोग. So I mean it may be possible कि your clustering of the data would be like this. तो जो जो आपको बिल्कुल सेंटर में दिख रहे हैं, दे ऑल आर इनवैलिड ट्रांजैक्शन. जो बाहर दिख रहे हैं, दे आर द वैलिड ट्रांजैक्शन. सो देन इन दैट केस हाउ यू कैन अप्लाई लीनियर? देयर इज नो पॉइंट इन, देयर इज नो वे टू अप्लाई, नो वे सो दैट यू कैन अप्लाई सम linearity in this. So this is known as the non-linear SVM. Now there are different ways to solve this linearity thing. Believe me, SVM only works with the linearity. SVM सिर्फ linearity पे काम करता है. If there is a non-linearity, there are different ways to handle that, and we will see क्या हमें which are the different ways how we can use this non-linearity. But any question about this till now? Linearity, non-linearity. अब हम लोग जो next topic पे जाने वाले हैं, which is the kernel. हम लोग kernel पे जा रहे हैं. The way it is the way to solve the non-linearity. But till now, and any question about whatever we have studied?
सर इसमें मार्जिन का डिफरेंस होता है, लाइक लीनियर में मार्जिन ज्यादा हो एंड नॉन लीनियर में मार्जिन कम हो, या वाइस वर्सा? इज देयर एनी डिफरेंस बिटवीन द मार्जिन?
Darpan, in the non-linear as well, there will be many ways. There will be many different ways. So you have to identify, the entire idea behind support vector machine is that you have to identify the hyperplane which maximize the margin. Now this hyperplane could be the linear hyperplane, it could be the polynomial hyperplane, or it could be the hyperplane like circle, what we are looking at right now. But ultimate objective is that we need to maximize the margin. right?
Got it.
Okay. Now, to understand this kernel trick, in fact, you look at the any material, the word they are using as a kernel trick only. Normally, we take trick literally in the negative meaning, but here it is not in negative meaning. Now, अब जो ये example यहाँ पे है, let us try to understand this example first, and then let us see that how we can solve this type of problem. So, for example, if suppose you are जैसे अभी कोरोना there is huge problem going on, and there is a testing of the vaccine is going on. So there is an appropriate dosage of the vaccine. For example, if suppose for the particular human, if you are giving less dosage, whether the vaccine will be effective, and the answer is no, vaccine will not be effective. If you are increasing the dose, at some point of time, the vaccine will start becoming effective. So, for example, if suppose this is my dosage, and as and when I'm increasing the dosage, this is a minimum dosage, and we can see here that with this minimum dosage, it is not resulting in a right observation. So basically here, this is a failed because vaccine is not affected. Here also vaccine is not affected. Here also vaccine is not affected. Here also vaccine is not affected. Here vaccine starts affecting. Again, now still you are increasing the dose. So vaccine is started increasing, affecting, and again affecting. Now after some time, because you have increased the dose in such a way that vaccine is now become the counterproductive. So from here, the vaccine is now not affecting the particular patient. So see, this is very typical type of the example now, because on the your vaccine is effective only in between. Vaccine is not effective in the beginning, not effective in the end, but it is only effective in beginning. Now whether we can have a linear classifier here, क्या हम लोग यहाँ पे linear classifier इस्तेमाल कर सकते हैं? And the answer is no. There is no way आप किसी भी वे में आप ये दोनों एरिया को कट हो सके वैसा आप लाइन ड्रॉ नहीं कर सकते. फॉर एग्जाम्पल इफ सपोज यू आर ड्रॉइंग लाइन फ्रॉम हियर टू हियर, देन this observation will be not right. If you are drawing line from here to here, then this observation will be in a wrong way. So here you cannot have a linear classifier. आप linear classifier नहीं कर सकते. तो अब क्या करना पड़ेगा? Anyone can guess anything?
सर वो सर्कल वाला था ना, सर्कल नॉन लीनियर क्लासिफायर.
हाँ, वो सर्कल वाला हम लोग कर सकते हैं. That is good idea. So basically you will draw a circle from here to here in such a way that radius will be this and center will be this, right? Shall?
Yes sir.
So this is one way, and actually this is very good observation. Now let me show you one more way. So here what we have done, we have increased the dimension. अभी तक इसका एक ही डायमेंशन था, अब हमने क्या कर दिया, इसके दो डायमेंशन कर दिए. We have multiplied each and every value by itself. हमने सबका स्क्वायर कर दिया. So that means के this value when you will square it, वो यहाँ पे कहीं जाएगी. इसको जब मैं स्क्वायर करूंगा तो यहाँ पे कहीं जाएगी, इसको स्क्वायर करूंगा तो यहाँ पे कहीं जाएगी, एंड देन एंड सो ऑन. इस हिसाब से ये मेरे स्क्वायर की वैल्यू बढ़ रही है, बिकॉज दिस इज द मैक्सिमम. इसको स्क्वायर करने के बाद मेरा मैक्सिमम वैल्यू यहाँ पे आ जाएगा. तो दिस इज वन थिंग. हाउ दिस हैज हेल्प? सो जैसे ही आपने इसको स्क्वायर किया, आपने इसका डायमेंशन इंक्रीज कर दिया. नाउ आप यू आर गोइंग फ्रॉम वन डायमेंशन टू द टू डायमेंशन, एंड जैसे ही आप टू डायमेंशन में गए, नाउ यू कैन ड्रॉ द लाइन इन सच अ वे दैट यू कैन डिवाइड दिस. तो ये आपका फील्ड ऑब्जर्वेशन आ गए, एंड नीचे उसके जो भी आएंगे वो सारे के सारे आपके ट्रू ऑब्जर्वेशन आएंगे. एंड दिस इज द एंटायर आइडिया बिहाइंड द कर्नल. Whatever non-linear classifier you are always using this kernel trick. हमने जो अभी जो कर्नल इस्तेमाल किया है, we have used the polynomial kernel. हालांकि शेल ने हमको एक सर्कल का इस्तेमाल करने का बोला था. सर्कल इज ऑल्सो वन एग्जाम्पल ऑफ द पॉलिनोमियल ओनली, बट we have used a simple polynomial kernel, like simply multiply the number by itself. So now even when we multiply, we are able to draw the line in such a way, we are able to draw the hyperplane in such a way that now your observations can be further subdivided. You know, this is mathematically proven. Now this is only example I have showed you, but it is a mathematically proven. Okay, if suppose you have a non-linearity, you can convert it to linearity by increasing the dimension. So for example, अगर one dimension में data है, अगर आप इसको two dimension में ले जाते हो, तो you can have a linearity. अगर two dimension में भी linearity नहीं आती है, go for the three dimension and then you can have the linearity. So as and when you increase the your dimension, you can have a hyperplane which is linear, and this is known as the kernel tree, जिसको हम लोग बोलते हैं kernel tree. All of you got it that why we are doing this thing? हमारा अल्टीमेट ऑब्जेक्टिव है हाइपरप्लेन, लीनियर हाइपरप्लेन हमें ड्रॉ करना है. Got
Sir?
it? Yeah.
So can't we have multiple linear classifier instead of going into the kernel trick?
For example, अगर if I talk about this example, how we can have, अच्छा, you want to divide in this, na, like this. This is one and this is another, na, something like this.
Yes, sir.
This is computationally heavy because whenever you talk about your support vector machine, lot of computation is been involved, and moreover, Darpan, this is a manual thing which you are supposed to do later on. So rather than we do it for all the observations, so apply one formula and then you can use it as a single linear classifier rather than dealing with two classifier at all the times.
Yes.
Okay, so this is polynomial kernel we have seen just now. There are lot many other kernels, like you have a Gaussian kernel, RBF kernel, sigmoidal kernel. RBF kernel is mostly used, ज़्यादा से ज़्यादा जो मैंने देखा है वो आपका RBF kernel को use होते हुए देखा है. Now, whenever there is a polynomial kernel involved, there is something called degree. ये जो degree D की बात हो रही है, this degree has to be given. Okay. Whenever you will apply this SVM practically through Python, आपको दो वैल्यू और पास करनी पड़ेंगी. One of the value will be your C, another value will be the gamma. Now, let me give you one more realistic example. We know that जो लोग ओबेस होते हैं, जो लोग थोड़े हेल्दी होते हैं ज़्यादा, उनमें हार्ट अटैक की संभावना बढ़ जाती है. या तो फिर एक और ज़्यादा अच्छा एग्जांपल लेते हैं. फॉर एग्जांपल, यू आर testing some drug on the particular type of the patient, and then you are realizing that this drug is effective to the younger people than the older people. So this drug is more effective to the younger people than the older people. So what you will do, आपका जो large margin classifier होगा वो क्या करेगा, एक एज डिवाइड कर देगा. मतलब जो भी 40 के नीचे हैं उन पे ये इफेक्टिव होगी, 40 की जो ऊपर होंगे उस पे वो इफेक्टिव नहीं होगी. Now, whether this is always true, मतलब 40 के नीचे वाले जितने भी होंगे उन सब पे हमेशा इफेक्टिव होगी, या 40 के ऊपर जितने भी होंगे उन पे हमेशा इनइफेक्टिव होगी? Is it something like that? And the answer is no. It may be possible that you have a people whose age is less than 40, लेकिन the drug is not effective on them. The reason could be anything. The reason could be that they have some other disease already, due to which this particular drug is not effective on them. Their body structure is not like that. For example, they are not fit, they are too heavy, too healthy, and due to that the drug is not effective on them. So due to all these reasons, it may be possible that you have some people whose age is less than 40 but still drug is not effective on them. Similarly, there will always be few people whose age is more than 40 and drug will be effective on them. because they are physically fit, they are doing regular exercise, regular jogging, regular yoga, and that is the reason the drug is effective on those people. So that means whatever SVM you are training, this SVM will be having some observations of different type in both the categories. So for example, if I look at here, so there will be some observation always which are like this. Wait. So you will be having some observations like this here. Some observations will be like this, and you will be having similarly below as well. You will be having some observations who who are falling into that particular category. So now these observations, they are known as outliers. ये जो भी जैसे यहाँ मैक्सिमम आपके जितने हैं वो सारे के सारे दे ऑल आर रेड बट देर आर फ्यू ब्लू. नीचे आप देखो मैक्सिमम ब्लू हैं बट देर आर वेरी फ्यू रेड रेक्टेंगल्स. दे आर नोन एज आउटलायर्स. नाउ व्हाई दे आर नोन एज आउटलायर्स? What is the dictionary meaning of outlier? Anyone can tell me that? What is this outlier? Something which is not falling in line, something which is not going according to the convention. This is known as the outlier. So this outliers, now you have a very typical question in mind. Whenever you will decide about the hyperplane, whether you should consider this outlier or you should not consider this outlier. Anyone?
Sir, but we can do, we can clean the data so it can get rid of outliers.
Kavya, I agree with that. Yesterday also someone has said that, and I said that you need to clean the data. Kavya, even after cleaning, there is a possibility that you may have some outliers. So we have to live with this very logic that outliers will be there. You cannot, of course, you can minimize with cleansing process, but few outliers will always be there. So whether you have to cover these outliers, and the answer is no. You cannot cover these outliers because they are not according to the population. They are outliers only. So why we should consider these outliers? So this value, the parameter which we were looking at, this parameter C, this parameter deals with this outlier. So you have to set the value of the C in such a way as and when you will increase the value of the C, it will increase the tendency to resist towards the outlier. So for example, अगर आपने C is equal to 1 लिया है, इसका सिंपल मतलब एक मीनिंग ऐसा मान के चलो कि वो एक ऑब्जर्वेशन को अलाउ करेगा एज आउटलायर. अगर आपने C is equal to 2 किया तो वो 2 ऑब्जर्वेशन को अलाउ करेगा. C is equal to 3 किया तो वो 3 ऑब्जर्वेशन को अलाउ करेगा. आई मीन दिस इज जस्ट एन hypothetical example, but again it largely depends on the total observation. आपके पास कितना total data कितना है. But as and when you will increase the value of the C, वो आपके outliers को consider करना शुरू करेगा as a regular population. So ये आप value यहाँ पे set कर सकते हो. There is something called bias variance trade-off, and I request all of you to note down this thing, bias variance trade-off, और आपको इसके बारे में पता करना है. Now just let me give hint to you. Whenever you are training any model, you are training it with the help of the training data. Now whether you want to develop a model that exactly fits with the training data but doesn't fit well with the testing data. So आप क्या कर सकते हो? You can develop a model which is very good according to the training data but not doing well according to the testing data. or you can develop the model which is not good according to the training data, but it is very good according to the testing data. So this is known as the bias variance trade off. इसके बारे में आप ज्यादा पढ़ेंगे, कुछ चीजें आपको मैं वर्क के लिए भी दे रहा हूं, बट bias variance trade off is all about that how well the model fits both training data as well as the testing data. Okay, now most important part, there is a library called sklearn, जिसको आप लोग scikit-learn भी बोलते हो, बट उसका जो लाइब्रेरी नेम है, it is sklearn. Whenever you want to implement any machine learning algorithm, you have to use this sklearn. आपको यूज करना ही पड़ेगा. Now you have a different type of classes or the functions available with this. So one of the function is that train test split. Now it is available in the library sklearn dot model under selection. और इसका काम क्या है? What is the role of this library, of this function? This function train test split function क्या करेगा? It will divide your data, whatever data you have, it will divide your data into randomly two separate groups. One is for training, another is the testing. Whatever ratio you will give, अगर आप ratio 80-20 देते हो, 70-30 देते हो, 50-50 देते हो, whatever ratio you are giving, it will split your data in this two groups for training as well as the testing. Then we have something called SVC, your support vector classifier. इसका जो नाम है, ये full form है इसका, but the class name is SVC. The class name is SVC. ये किस में अवेलेबल है? sklearn.svm नाम की जो लाइब्रेरी है उसमें अवेलेबल है. And this is the most important class. अगर आपको SVM implement करना है, then you have to use this class called the SVC. So this SVC class, for example, SVM के लिए SVC class है. इसी तरह हर एक के लिए, for example, if I talk about your artificial neural network, तो उसके लिए जो क्लास है वो NLP है. NLP हर एक के लिए अलग अलग क्लास है. Whatever machine learning technique you are using, you have to use appropriate class. Now there is something called grid search CV, and so जैसे yesterday I told you that there is something called cross validation, and you have to find out what does this cross validation is all about. Now what does this grid search CV is doing? Now उससे पहले हम लोग वापस यहाँ पे आते हैं. तो हमने देखा था कि आपको ये C की जो वैल्यू है, you are supposed to set this value of the C. So you will start with value 1, then 2. How you will realize that this is the best value? आपको कैसे पता चलेगा कि this is the best value? You have to try everything. You have to start from 1, 2, 3, 4, 5 till 10,000. You have to try every value, and whatever value is giving you the best result, best parameters, you will take that value. All of you agree with me? So इसको हम लोग बोलते हैं parameters. They are known as the parameters. So this grid search CV, now actually you are supposed to manually do everything. आपको एक एक करके सारा करना चाहिए. But in the grid search CV, the full form of CV is a cross validation. तो इसका जो full form है grid search cross validation. Now what does it is doing? आप क्या करोगे? आप इसको बहुत सारे पैरामीटर्स एक साथ दे दो, and what it will do, it will test all these parameters one by one. आपको मैन्युअली करने की जरूरत नहीं है. It will do one by one, and whatever is the best parameter, it will return the best parameters to you. तो इससे बहुत सारा काम आसान हो जाता है. अगर आप इसको यूज नहीं करते तो then you have to use manually. जो मैंने आपको कल कोड शेयर किया था, we are using this. तो आज भी हम देखेंगे इसको. So this is a grid search cross validation. Confusion matrix is all about finding accuracy, precision. If suppose you want to find out all these things, then you have a function called confusion matrix. Now ये चार में से there are two functions. One is a train, test, split, and confusion matrix. And SVC and grid search SVC, they both are the classes. ये hyperparameters को calculate करने के लिए we are using this grid search CV. So Uh, before we go into step by step this, let us first of all try to understand this confusion matrix. So, what is this confusion matrix, and what is this true positive, true negative, your actual predicted? So, let us try to understand the entire this structure. Now, so on the left hand side, because this is a classification, there are only two possibility. One is a positive possibility, another is a negative possibility. So for example, you are checking for the diabetes. So either diabetes is there or diabetes is not there. And even if you're predicting the diabetes, again, you are predicting diabetes is there or you are predicting that diabetes is not there. So there are only two possibilities. So here there is a positive and there is a negative. Now, if suppose actually there is a positive and you predicted positive, so actually it is positive and you have predicted that it is a positive, it is known as the true positive because you have predicted rightly positive. Now, actually, it is positive, but you are predicting that it is not positive; it is negative. So, whatever model you have developed, the model is predicting that it is not positive; it is a negative. Now, believe me, I am not saying that this is wrong. It may be possible that it is due to outlier. There is a high possibility that it is due to the outlier. But then we will call it as a false negative because it has predicted the negative which was actually positive. That is why it is known as the false negative. Now, if suppose your actual class is negative, but you are predicting that it is positive, that means you are wrong predicting. But that means you are wrong predicting positive value. That is why it is known as the false positive. And if suppose it is actually a negative and you are predicting that it is a negative, then it is known as the true negative. Now, any confusion about this four values? Anyone? All of you clear about this thing? Then we can move for other things.
So type 1, type 2 error.
हाँ सी ये जो कंफ्यूजन मैट्रिक्स है ना, इट इज नॉट द idea of the computers. In computer, you will realize those who are doing IoT specialization, they must realize that we are borrowing lot many things from electronics. Even mechanical IoT के अंदर तो those who are doing data science, they will realize that there are lot many things are there which we are borrowing from statistics. Even in fact, in the current semester, your all the data science courses will be taught by the statistics people only. Reason is that okay, these are the subjects which are more closer to statistics, and similarly, this confusion matrix is a concept which came from the statistics only. So statistics के अंदर, if you are having a false positive, then this is known as the type 1 error, and if you are having a false negative, this is known as the type 2 error. There is no particular meaning about it, but they are known as type 1 error and type 2 error. See, in the entire four, true positive, true negative, false negative, two are positive. That means the true positive and true negative are the right is expected output. But these are errors. And इसको नाम तो कुछ देना ही था, तो we are given the name type 1 error and this is given the name as a type 2 error, right? But ये कैसे true positive, true negative, clear about that?
Yes.
Okay. Now, so from this we can calculate lot many things. For example, if suppose I want to calculate the precision, मतलब अब with what precision I am able to calculate the true values. मेरी जितनी भी true values हैं, अगर मुझे वो सारी calculate करनी होगी, तो with what precision I am able to calculate the true values. So the formula will be true positive divided by true positive plus false positive. And if suppose I want to calculate the accuracy, so what will be the accuracy? Accuracy will be my this value plus this value divided by all four. That is accuracy. With what accuracy I am calculating the value. So there is a true positive plus true negative divided by all the four cells. So there is something called sensitivity, there is something called specificity. We will not go in detail of that. For us, accuracy, precision, F1 score, and recall, they are much important. So this is how the confusion matrix is organized, and you can always use this confusion matrix. You will see, you will calculate as well. So with this, we are completing the theoretical part in exactly 1 hour. Any question about the this theory SVM before we go to the practical implementation of the SVM?
एक्यूरेसी और प्रिसीजन एक ही हुआ ना?
एक्यूरेसी और प्रिसीजन एक ही हुआ नहीं शैल, एक्यूरेसी और प्रिसीजन इस हिसाब से अलग अलग हुआ. इन द एक्यूरेसी you are considering the your negative observations as well. So normally whenever you are doing any computation, we are more focused on the positive part. For example, मैं कैंसर डिटेक्शन की बात करूं तो कैंसर डिटेक्शन के अंदर सिंपल एग्जांपल हम लोग लेते हैं कि कितने राइट कैंसर उसने डिटेक्ट किए. सो बेसिकली हम क्या कर रहे हैं, वी आर ओनली लुकिंग एट द पॉजिटिव पार्ट. दैट इज ऑल अबाउट द प्रिसीजन. लेकिन अगर आप नेगेटिव भी उसमें ऐड करते हो, इट इज नोन एज द एक्यूरेसी. एक काम करते हैं, दैट इज गुड क्वेश्चन. उससे से मुझे एक लोग एग्जाम्पल भी ट्राई करते हैं, देन यू विल बेटर रियलाइज. सो लेट मी ओके. सो इफ सपोज दिस इज अ कैंसर डिटेक्शन एंड हम इसको ऐसा एज्यूम करते हैं कि एक कैंसर डिटेक्शन सिस्टम है. ओके, नाउ कैंसर डिटेक्शन सिस्टम के अंदर आपके पॉसिबल वैल्यूज क्या होंगी? पॉजिटिव, नेगेटिव. दैट मीन्स डिटेक्टेड राइटली और नॉट. तो कैंसर पॉजिटिव है कि नहीं है, या फिर इसके काम करते हैं ट्यूमर है कि नहीं है. नहीं, ट्यूमर इज कैंसर ओनली. तो यस या नो, राइट. एंड सिमिलरली दिस इज माई एक्चुअल वैल्यूज. ये मेरी एक्चुअल वैल्यूज हैं. These are my actual values. Now similarly I will be having the predicted values. So this will be my predicted values, and again in the predicted values as well there will be yes and no. So there will be yes and there will be no, right. अगर उसने सही प्रेडिक्ट किया तो यस है, अगर सही प्रेडिक्ट नहीं किया तो नो है. नाउ एज्यूम करते हैं कि मेरे कुल मिला के देर आर 1000 ऑब्जर्वेशंस. टोटल ऑब्जर्वेशंस आर 1000. अभी हम एक्चुअल की बात कर रहे हैं. एक टोटल ऑब्जर्वेशंस में से जो एक्चुअली यस हैं और एक्चुअल नो है, ये दोनों फॉर एग्जांपल 500 है. इस हिसाब से कुल मिला के वो टोटल हुए. नाउ एंड देन ये जो एक्चुअल यस थे जो 500 थे, जिसमें से जो प्रेडिक्टेड वैल्यू आया, सो दिस इज माय प्रेडिक्टेड यस एंड दिस विल बी माय प्रेडिक्टेड नो. सी इट इज ऑलवेज पॉसिबल ना, आपका एक्चुअल यस है लेकिन सिस्टम उसको सही से प्रेडिक्ट नहीं करे. सो फॉर एग्जांपल 480 को सही प्रेडिक्ट किया, लेकिन 20 जो बचे थे वो उसने गलत प्रेडिक्ट किए. नाउ 500 ऑब्जर्वेशंस जो जिसमें ट्यूमर नहीं था, उसमें से उसने जो नहीं प्रेडिक्ट करने वाला फॉर एग्जांपल 450 था, और जो बाकी 50 थे वो गलत प्रेडिक्ट किए. मतलब ट्यूमर नहीं है बट उसने प्रेडिक्ट क्या किया, उसने प्रेडिक्ट कर लिया कि ये आपका ट्यूमर है. तो इन दैट केस दिस विल बी योर एंटायर, ये आपका टेबल बन गया. नाउ हमारा प्रिसीजन क्या था? प्रिसीजन वॉज आपके एक्चुअल यस कितने हैं डिवाइड बाय समेशन ऑफ टोटल यस, ओनली दिस वैल्यू. तो आपका प्रिसीजन कितना आया? ये आया. बट व्हेन यू टॉक अबाउट द एक्यूरेसी, मतलब उसने सही तरह से कितने प्रेडिक्ट किए, उसने सही तरह से ये भी प्रेडिक्ट किया, उसने सही तरह से ये भी प्रेडिक्ट किया, उसने ये गलत प्रेडिक्ट किया हुआ है, लेट मी पुट इट विद सम डिफरेंट कलर, उसने इसको सही तरह से प्रेडिक्ट किया, उसने इसको भी सही तरह से प्रेडिक्ट किया है, ये उसने रॉन्ग प्रेडिक्ट किया है, और ये भी उसने रॉन्ग प्रेडिक्ट किया है. So if I want to find out the accuracy, my accuracy will be is equal to summation of all the right predictions. Now which are the right predictions? This and this, whole divided by all the observations. My total observations are 1000. I know I can simply write here 1000. मैं सीधा 1000 भी लिख सकता हूँ. Now उसके बदले अगर मैं चाहूँ तो मैं यहाँ पे इन सब का summation भी ले सकता हूँ. I can do that. That's fine. So what I can do, I can write the summation of all this. Summation of all this. Again, the value will be same. So this is my precision and this is my accuracy. Well, now got it? In the precision, we are only considering the predicted true values, and whenever you are going for the accuracy, you are considering all, right? See the formula? Precision will be true positive divided by summation of both this. And as far as accuracy is concerned, we are actually getting which are the right observations divided by all the observations. Shall now clear?
Yes, sir.
Okay. Now here you will notice कि accuracy 0.93% है, लेकिन precision कम है. Ideally, whenever you are calculating this accuracy or the precision, वो दोनों आपके लगभग same होने चाहिए. Okay. So any other question?
Sir,
Yeah.
so what if we change the outliers? Because outliers is something which went into the other side of the data. We can say that like.
Mm-hmm.
So what if we change that data towards that side only?
How we can do that, Darpan? See,
It,
Darpan, it is very easy, very difficult to identify the outlier. आप आउटलायर को इतना आसानी से आइडेंटिफाई नहीं कर सकते because they look like your that particular class only. But they are there, and in the real world as well, they will always be there. So never try to completely remove this outlier. This अगर ये outlier आपके सिस्टम में रहेंगे, वो रियल वर्ल्ड फिनोमेना को रेप्लिकेट करता है. अगर किसी में आउटलायर नहीं है तो समझ लेना कि वो डेटा फैब्रिकेटेड है, बिकॉज देर इज it is extremely difficult, if not impossible, to get the 100% accuracy, because in the real world there will be the outliers. There is no chance. For example, आप देखो, this is a winter going on and we are expecting rain in the winter, no? Now, don't you think that this is the outlier?
yes, sir. But
Now,
sir, basically outlier is due to the false. We can consider it as a false input from the source also. No?
outlier can be there due to the false input from the source. These things can be removed and it has to be removed, but you cannot make it to the zero. आप इसको जीरो नहीं कर सकते. मैं आपको सिंपल एग्जांपल बताऊं. फॉर एग्जांपल, दिस इज अ विंटर सीजन गोइंग ऑन एंड Delhi side pe rain is there. So you will think that it is an outlier, but that is not the outlier. It is a real data. It is not due to any faulty instrument. It is not due to any mistake by the sensor. But it is the real data. So outlier will be there, but you cannot always remove the outlier because they are also the part of the real world data.
Okay.
Wherever there is a problem with the sensor, of course you should remove those things. But if there is a problem with the sensor, then definitely it would have affected the other data as well, your authenticated data as well. So outliers are very tricky things. We cannot run away from them. If I talk about, for example, my stock prediction, somewhere in this month of March, suddenly the entire stock market of entire world was down. Now, uh, I may remove them as outlier, but they are not the outlier. They are the real world situation, and I should not remove them. My algorithm should be equipped enough to deal with these outliers with the relative accuracy,
Okay.
right?
Yes,
Okay.
sir.
Okay. Now we are completing theoretical part, and okay, I am removing this annotation. I don't want to keep. Now we are moving to Jupyter, and those who have installed through Anaconda, they can directly double click on the icon, but I have installed through pip, so I have to run my Jupyter through command prompt. Okay, so my Jupyter is started now, and let me open new notebook. My new notebook is open. Um, I hope all of you know how to operate with Jupyter. Anyone is having any query about that? So yesterday I shared one program with you. Those who have tried, they already know that there is something wrong with the program, and so now you please look at the. Um, okay, I have to. Let me open it in Notepad, and one by one I will copy everything. So this is my program, and so I need to import few first of all libraries. So I've imported CSV. Now this CSV is there to read the CSV file. See, whenever you will deal with the machine learning, the CSV file is very important. Whatever data you are transferring, whatever data you are reading, it has to be in CSV only. Of course, Excel भी चलेगा, but majority of the times we are using the CSV. Those who have done data science, they know the importance of pandas. Pandas library machine learning के लिए बहुत ज़्यादा important है. We have seen about sklearn, model selection, SVM. From that we can import SVC. मॉडल सिलेक्शन हमने इंपोर्ट किया ग्रिड सर्च सीवी, और हमने मैट्रिक्स से इंपोर्ट किया कंफ्यूजन मैट्रिक्स. सो लेट मी राइट दिस थिंग एंड लेट मी रन दिस. तो सक्सेसफुली रन हो गया, एंड let me go to the next step. Now before that, let me go to the steps हमने जो बीच में skip कर दिए थे. Okay. So ये सबसे पहला हमारा स्टेप क्या होगा फॉर एनी मशीन लर्निंग एल्गोरिथम? माय फर्स्ट स्टेप विल बी टू रीड द डेटा. So my data would be available either in Excel file or CSV file. Most of the times I will read the data in step number 1. इनफैक्ट इसके बाद जो मैं आपको एक टास्क देने वाला हूँ, उसकी भी द CSV file Darpan will share with all of you. And then whatever operations we are doing right now, you have to perform all this step-by-step operations on that particular data, and then you have to find out the accuracy. Step number 2, we need to split the data into training and test data. So this is my step number 2. मेरा जो भी पूरा data है, step number 1 में I need to read the data. So first of all, let me read the data. So this is my step number 1, and okay. there might would be a problem. The problem is, anyone can guess what is the problem?
The
सर
file not
आपने वो CSV फाइल वो पर्टिकुलर फोल्डर में नहीं डाली होगी.
राइट राइट, तो हम एक काम करते हैं, डालते नहीं है, हम उसका पाथ ही चेंज कर देते हैं ना. लेट मी सी व्हाट इज ओके. इसका पाथ चेंज कर देते हैं पूरा का पूरा, तो सीधा वहीं से वो रीड करेगा. ओके, इसको PWD करके एक बार फिर से चेक कर लेते हैं. राइट, नाउ लेट मी रन द कोड. अब उसी कोड को फिर से रन करेंगे एंड देन इट विल रीड. ओके, उसने रीड कर ली है. If I want to check whether it is read properly or not, so I can simply print either X or Y. So simply X I will write here, and I will press and Control Enter, and I will see कि data is there. यहाँ पे मेरा पूरा data आ गया है. So एक बार ये Excel फाइल को ओपन करके भी चेक करते हैं. This is Pima Indians diabetes. Now this is data which is a diabetes data. So honestly, I don't know which are these values. This may be the blood pressure, this may be the pH level, it could be anything. But ये जो पहले A, B, C, D, E, F, G, H, जो पहले आपके 8 कॉलम हैं, they are the inputs. ये आपके X values हैं. ये जो आखिरी वाला है, this I, this is the output. मतलब 1 का मतलब है डायबिटीज है, 0 का मतलब है डायबिटीज नहीं है. 1 का मतलब डायबिटीज है, 0 का मतलब डायबिटीज नहीं. नाउ यू विल ऑब्जर्व वन थिंग वेरी वेरी इंपॉर्टेंट. जितने भी आपके 125 के ऊपर वाले हैं वो सारे के सारे डायबिटीज वाले हैं. जैसे 48 यू कैन सी 1, लेस देन 125 0, 183 यस नो यस नो, देन सी दिस इज द एक्सेप्शन. ये आपका एक्सेप्शन. बट आई विल नॉट से दिस इज द आउटलायर. लेकिन जब आप इसको एक हाइपर प्लेन के ऊपर जब आप इसको मल्टी डायमेंशन में प्लॉट करेंगे, यू विल गेट अ बेटर आइडिया. सो आपके पास ऐसा डेटा है, दिस इज अ डेटा. नाउ वी वांट टू रीड द दिस पर्टिकुलर डेटा एंड वी हैव रेड दिस डेटा. हमने डेटा को कैसे रीड किया, लेट अस ट्राई टू अंडरस्टैंड दैट. सबसे पहले PD, व्हाट इज PD? PD इज pandas, PD.read CAC, और यहाँ पे हमने क्या दे दिया, हम लोगों ने यहाँ पे फाइल का नेम दे दिया. तो 0 से लेके 7 मतलब पहली 8 कॉलम उसको हम लोगों ने रीड किया और इसको लिस्ट में कन्वर्ट करके हम लोगों ने X, कैपिटल X में डाला. Why we have not put it in a small x? Because small x is only the single value. जब हम कैपिटल X की बात करेंगे, that is the combination of all the 8 columns. Small x will be the only one column. X1 will be one column, X2 will be another column, X3 will be another column. But when I will put everything together, I have to make it capital A. Similarly, जब अगर मैं यहाँ पे y करता हूँ तो I will get the last my 0 1 0 1 and so on. So डेटा मेरा रेड हो गया, ये डेटा मेरा मैंने रीड कर लिया. माय स्टेप नंबर okay, step number 1 done. I have read the data. Any query about this? Step number 1, how to read the data. See, this is not the only way. There are 5 or 6 different ways. You can use any of the way. The final bottom line is that whatever data you want to read, that data has to come somewhere here. वो data यहाँ पे कहीं आपका एक पांडा की डेटा फ्रेम के अंदर वो आपका डेटा आ जाना चाहिए. दिस डेटा इज अ डेटा फ्रेम, ये आपकी डेटा फ्रेम है. Now, next, let us go to the next step. Next step is to split the data into training and testing set. So let me now split. Before that, what we can do, एक चीज और अच्छी करते हैं हम लोग. Let us see what we have done here. If I want to write length, print length of capital X and length of small y. So you will see कि 767 नंबर आया. Now what does that mean कि X वाली लिस्ट के अंदर 767 ऑब्जर्वेशन हैं, वाई वाली लिस्ट के अंदर भी 767 ऑब्जर्वेशन हैं। नाउ वी आर स्प्लिटिंग, अब हम इसको स्प्लिट करते हैं, विच इज माई स्टेप नंबर 2। तो जैसे ही मैं इसको स्प्लिट करूंगा, मुझे कोई आउटपुट नहीं मिला क्योंकि स्प्लिट ऑलरेडी हो गया है। एंड नाउ लेट मी सी द लेंथ ऑफ ऑल दिस। प्रिंट x अंडरस्कोर कैपिटल X अंडरस्कोर train and small y अंडरस्कोर train, एंड आई बिलीव कि दोनों सेम होने चाहिए। फिर मैं प्रिंट करता हूं, प्रिंट कैपिटल X अंडरस्कोर टेस्ट एंड स्मॉल y अंडरस्कोर टेस्ट, राइट? एंड लेट मी रन दिस नाउ एंड यू विल सी, ओके सॉरी मुझे यहाँ पे लेंथ करना था, this is my mistake. I am not interested in the entire data. I just want to know the length. So let me write here length. Okay, sorry, यहाँ पे because we have added. Okay, now you will see कि 767 को इसने कैसे स्प्लिट किया। My training data is a 613 and my testing data is a 154. ये उसने क्यों किया? क्योंकि हमने टेस्ट साइज कितना दिया हुआ है, यहाँ पे टेस्ट साइज हमने दिया है 0.2। अगर मैं इसी को बढ़ा के 0.3 कर देता हूं, and then if I run this code, that means my data will be divided into the ratio of the 70:30। इससे पहले हमने किस में डिवाइड किया था? 80:20 में। So with the test size given here, you can always have the appropriate ratio. Clear the step number 2? So the function which you are going to use is a train test split. कैपिटल X आप पास करोगे, विच इज अ लिस्ट ऑफ द X वैल्यूज, कैपिटल Y लिस्ट ऑफ द Y के वैल्यूज। टेस्ट साइज पास करोगे, आपको रेंडमाइज करना है, शफल करना है कि नहीं करना है, वो आप यहाँ पे पास करोगे। व्हाट इट विल रिटर्न? इट विल स्प्लिट द डेटा, X डेटा को वो रेशियो में स्प्लिट करेगा, दैट विल बी द फर्स्ट टू लिस्ट, एंड Y को अगेन स्प्लिट करेगा, दैट विल बी अनदर टू लिस्ट। So any question about this? All of you clear now how we have done split of the training and testing data from the same observations? Now let us go for the step number 3, and step number 3 is going to be very interesting. And so in the step number 3 we need to find out the appropriate hyperplane. हमें appropriate hyperplane identify करने हैं। and so step number 3, see, let us understand each and everything one by one. So in the step number 3, first of all you have created the object of the class SVC जो हमने ऊपर import किया। then यहाँ पे here you are supposed to pass these parameters. So these are the group parameters. So सबसे पहले what kernel you want to keep. You will see here कि यहाँ पे जो मेरा कर्नल है, कर्नल यहाँ पे क्या देना चाहिए मुझे? लीनियर है, RBF है, पॉली है, मुझे क्या कर्नल देना है? C की कौन कौन सी वैल्यूज मुझे ट्राई करनी है? 10, 20, 30, 40, 100। गामा की कौन कौन सी वैल्यूज मुझे ट्राई करनी है? इफ इट इज अ पॉलिनोमियल, अगर वो पॉलिनोमियल है तो मुझे डिग्री कौन सी ट्राई करनी है? डिग्री 2 ट्राई करनी है, 3 ट्राई करनी है, 4 ट्राई करनी है। दिस ऑल थिंग आई एम सपोज टू पास हियर। ये मैं एक पूरा बंडल बनाऊंगा, क्लस्टर बनाऊंगा, एंड एंटायर थिंग आई विल गिव टू दिस ग्रिड सर्च सीवी। मैं क्या करूंगा? ये पूरे को मैं ग्रिड सर्च सीवी में यहाँ पे दे दूंगा। तो माई एस्टिमेटर विल बी CLF. व्हाट इज CLF? CLF इज द इंस्टेंस ऑफ द SVC, मेरा जो सपोर्ट वेक्टर क्लासिफायर है वो। व्हाट विल बी द पैरामीटर ग्रिड, जो मैंने अभी ऊपर पैरामीटर्स डिफाइन किए वो। CV वैल्यू मुझे क्रॉस वैलिडेशन कितना करना है? मुझे 5 करना है। So this way you can use the grid search CV. Now what it will return? ये रिटर्न क्या करेगा? ये आपको बेस्ट स्कोर देगा और आपको पैरामीटर्स जो भी कौन से बेस्ट पैरामीटर्स हैं वो आपको वो रिटर्न करेगा। इवन लेट अस प्रिंट द रिजल्ट एज वेल ना, इसको भी हम प्रिंट करते हैं। एंड लेट मी रन दिस नाउ। आप लोगों ने देखा होगा डेलिबरेटली मैंने यहाँ पे इसको ये कमेंट में डाला हुआ है। अगर मैं इसको इसी सिचुएशन में कमेंट से हटा के रन करता हूँ ना, इट विल टेक एटलीस्ट हाफ एन आवर, ये कम से कम हाफ एन आवर लेगा, क्योंकि देन इट विल ट्राई लीनियर, इट विल ट्राई आरबीएफ, इट विल ट्राई पॉली, it will try all the value of the C, 10, 20, 30, 40, 50, 100, all the values of the gamma 1, 2, 3 and so on. इसलिए मैंने दिस प्रोग्राम आई हैव ऑलरेडी डन लॉन्ग बैक, और मैंने इसको रन करके टेस्ट करके देखा हुआ है। इसका जो बेस्ट कर्नल आता है वो लीनियर आता है, और C की वैल्यू आई थिंक 0.5 आती है, गामा की वैल्यू आई थिंक 0.3 आती है, वो हम लोग देख लेते हैं। इसमें डिग्री की जरूरत नहीं है, क्योंकि इसमें आपका लीनियर है, डिग्री वहीं पे काम लगेगा जहां पे आपका पॉलिनोमियल आता है। सो लेट मी रिमूव दिस पार्ट। ओके, नाउ लेट मी रन दिस एंड यू विल सी कि इसका आउटपुट आपका इमीडिएटली नहीं आएगा। एंड एक और चीज जो मैं आपको बताना चाहता हूं वो ये है कि लेट मी ओपन माय टास्क मैनेजर, and you will see here the CPU utilization. What is my CPU utilization here? अभी see it was 100% earlier, now it is the 50%, अभी 50% हो गया है, बिकॉज उसका रिजल्ट आ गया होगा। see, ये उसका रिजल्ट है। तो मैं कहां पे इंटरेस्टेड था? मैं इंटरेस्टेड था ये वैल्यूज में, ये दो वैल्यूज, इस टू वैल्यूज। The best result is 0.77 accuracy. For which value? For the C value 0.4, the gamma value 0.02 and the kernel is a linear. ये जो entire आया है वो आपका रिजल्ट आया है। Now, अगर आपको RBF भी ट्राई करना है, we can do that and then थोड़ा सा और ज्यादा इसको ओके इसको रन करते हैं, इसको कमेंट में डाल देते हैं एंड इसको रन करते हैं। लेट अस सी एंड देन यू विल सी, मैंने इसको रन किया। अब आप यहाँ पे CPU यूटिलाइजेशन देखो, दिस इज रेयरली यू विल बी एबल टू सी। i5 प्रोसेसर है मेरा और 8 GB की रैम है, जो लगभग पूरी यूटिलाइज हो रही है इन द मशीन लर्निंग एल्गोरिथम। आप जब गेम खेलते हो प्रॉब्ली एट दैट टाइम आप ये CPU यूटिलाइजेशन देखते होगे, बट यू कैन नाउ एज्यूम कि व्हाट इज द अमाउंट ऑफ कैलकुलेशन गोइंग ऑन, ये जो कैलकुलेशन कितना हैवी कैलकुलेशन जा रहा है फॉर एनी मशीन लर्निंग algorithm. So, ये जब तक रन होता है तब तक एनी क्वेश्चन अबाउट दिस? सो वो जो क्रॉस वैलिडेशन हम कर रहे थे, इट इज टू फाइंड आउट द बेस्ट हाइपर पैरामीटर्स, whether linear has to be selected, whether RBF has to be selected, whether poly has to be selected. उसके लिए we are using this grid search CV, क्रॉस वैलिडेशन हम लोग कर रहे हैं। ये होता रहेगा पैरेलली, हम कुछ और भी शुरू करते हैं। सो दिस इज माय स्टेप नंबर 3। स्टेप नंबर 3 मेरा क्या था? आई नीड टू फाइंड आउट द बेस्ट हाइपर पैरामीटर। हाइपर पैरामीटर क्या है? गामा की वैल्यू है, सी की वैल्यू है, विच कर्नल आई एम सपोज टू यूज, तो दैट इज अ हाइपर पैरामीटर। Step number 4 will be the training the model. Now, in the training the model, it is one of the easiest thing to do. So this is my step number 4. Let me take from here. So ट्रेन करने के लिए वेरी सिंपल, यू हैव टू यूज द फंक्शन फिट। तो जैसे आप फिट यूज करोगे, इट विल स्टार्ट ट्रेनिंग द मॉडल। लेट मी रन दिस एज वेल, साथ में होता रहेगा। एंड सो वंस द मॉडल इज फिट, जब भी आपका मॉडल फिट हो जाता है, आपका नेक्स्ट टास्क क्या होगा? द नेक्स्ट टास्क विल बी टू इवेल्युएट द मॉडल। Evaluation in the means of the accuracy, in the means of the precision, उसके बेस पे हमें इसको इवेल्युएट करना है। एंड उसके लिए वी हैव टू, my code will look like this. Step number 5, I need to calculate confusion matrix। और जो हमने वहां पे देखा था, देखो याद करो हमने क्या किया था वहां पे, हम लोगों ने वहां पे एक्यूरेसी फाइंड आउट की थी। कैसे एक्यूरेसी फाइंड आउट की थी? बाय एडिंग दिस टू, डिवाइड बाय ऑल ऑब्जर्वेशन। सिमिलरली प्रिसीजन कैसे कैलकुलेट किया था? रिकॉल इस हिसाब से कैलकुलेट करेंगे। एंड F1 स्कोर विल बी, उसकी फॉर्मूला है दिस वन। एंड इन द एंड वी आर गोइंग टू प्रिंट ऑल दिस थिंग्स। काम करते हैं। Let me copy entire thing. Okay. I am sure it will take a lot of time because see, 100% CPU utilization, 72% memory utilization. I really don't know कब तक ये रुकेगा. Anyone knows how to um, stop this? I can do. Okay. तो इंटरप्ट नहीं हो रहा है. Anyone knows how to do this? तो इसको सेल को बंद करना, एग्जीक्यूट करना. ओके, उसको मैंने कट कर दिया. आई डोंट नो बैकग्राउंड में अभी भी रन हो रहा है कि नहीं हो रहा है. लग तो रहा है कि रन हो रहा है.
सर उसको चेंज कर देना था ना, ऊपर वाले को कमेंट में डाल के नीचे वाले को अनकमेंट करके एग्जीक्यूट कर देना था, तो लीनियर में आ जाता वापस.
हाँ, लेकिन उसके लिए वो एग्जीक्यूशन तो स्टॉप करना पड़ेगा ना, वो नहीं हो रहा था. एनीवे, लेट अस वेट फॉर सम टाइम and then we will apply. So let us understand this. Step number 4 may we have trained the model. How to train the model? With the help of this fit function. Now once you have trained the model, you need to predict new value. आप क्या करोगे? आप x की वैल्यू डालोगे. आपने क्या किया? इसको x की टेस्ट वैल्यू दे दी and then you have predicted the value of the y. Now this predicted value of the y, when you will pass with the actual value of the y, कहाँ पे आप पास करोगे? कंफ्यूजन मैट्रिक्स में पास करोगे. आपको क्या मिलेगा वहां पे? आपको मिलेगा वहां पे आपके ट्रू पॉजिटिव, ट्रू नेगेटिव, फॉल्स पॉजिटिव, फॉल्स नेगेटिव, ये सारी वैल्यूज मिलेगी. यू कैन यूज दिस वैल्यूज to calculate accuracy, precision, recall and F1 score. Now किसी के माइंड में ये भी क्वेश्चन आ सकता है कि सर, can we calculate this accuracy directly? Can we calculate the precision directly? And the answer is yes. Even ये जो confusion matrix है, इसी के अंदर ऐसे बहुत सारे फंक्शंस अवेलेबल हैं जिससे आप एक्यूरेसी को डायरेक्टली कैलकुलेट कर सकते हो, प्रिसीजन को डायरेक्टली कैलकुलेट कर सकते हो, रिकॉल को भी डायरेक्टली कैलकुलेट कर सकते हो. सो ये जब तक आता है तब तक हम लोग गूगल कोलैब पे भी देख लेते हैं. आई डोंट नो कितना टाइम लेगा ये. लेट मी ट्राई टू फाइंड द प्रोसेस. उसको बंद करते हैं. ओके, आई बिलीव कम हो गया. राइट. सो अब इसको रन करते हैं, ट्रेनिंग वाले को. एंड सो द मॉडल इज ट्रेन नाउ एंड लेट मी रन दिस. So as and when I will run, I am getting accuracy as the 0.76. I am getting precision as a 0.87, recall as a 0.77, and F1 as a 0.82. So with the help of this confusion matrix, we have calculated this. Directly भी कर सकते हो. There are a lot many functions available to find out the accuracy, to recall and find the recall and so on. So this is how you can read the data. You can split it into training and testing data. You can find the best hyperparameter. You can train the model and you can evaluate whether it is right model or not. So any question about any of the steps?
Sir, regarding third step.
Step number 3, where is third? What is the identifying the best hyperparameter? Okay, this one. Just 1 second. हाँ, this one नहीं, वो तो हमने डिलीट कर दिया. Anyway, यहाँ पे आ जाते हैं. This one, दर्पण.
Yes, sir. Sir, इसमें like in the first C there are the values in 10, 20, 30, and in the another line you mentioned in the linear that is in the decimal point. So is there any difference like that?
Good question, Darpan. See, um, it is quite possible that you give all the possible values in one shot. So what I can do, I can write here 1, 2, 3, 4, 5, 6, up to 100, all the values. There is one more thing, always remember, you cannot pass your range. आप यहाँ पे range pass नहीं कर सकते. You are supposed to pass your fixed values, discrete values. तो जैसे आपने 1 लिखा, it will first of all check for the c is equal to 1, then it will check for the c is equal to 2, which is written next. In this case, सबसे पहले वो क्या चेक करेगा, c is equal to 10, उसके बाद क्या चेक करेगा, c is equal to 20, उसके बाद क्या चेक करेगा, c is equal to 30. राइट नाउ, अगर मेरा c is equal to 10 आया, दैट मीन्स कि देर इज अ पॉसिबिलिटी दैट मेरे c की वैल्यू कम भी हो सकती है फॉर द ऑप्टिमल पैरामीटर. तो फिर मैं क्या करूंगा, आई हैव टू चेक फॉर c इज इक्वल टू 1, c इज इक्वल टू 2, 3, 4, 5, 6, 7, 8, 9, 10. जब मैंने उसके साथ रन किया तो मेरा जो ऑप्टिमल पैरामीटर आया c, वो आया 1. दैट मीन्स कि वो 1 तो इसलिए बिकॉज इट इज इन द एज, वो बिल्कुल एंड पे है. दैट मीन्स कि मेरे c की वैल्यू उससे कम भी हो सकती है. So then I have to try something else as well, मतलब 0.2, 0.5, 0.7, 0.8, और उसमें से कोई भी एक मेरा ऑप्टिमल वैल्यू आना चाहिए. एंड दैट इज द रीजन, जब भी आप लोग whenever you are identifying this hyper parameter, you have to do lot many trial and error. ये एक शॉट में कभी भी नहीं आएगा, आपको बहुत सारा ट्रायल एंड एरर कॉम्बिनेशन करना पड़ेगा, तब कहीं जाके ये आपका फिट होगा, सेट होगा. राइट दर्पण?
Okay, sir.
Any other question?
And sir, in gamma also we have taken like that 1, 2, 3, 4, and in the another
हाँ,
line decimal thing.
एंड द रीजन इज दैट दर्पण कि जब मैंने इसको पहली बार रन किया तो गामा इज इक्वल टू 1 आया, फिर मैंने कम कर दिया. मैंने क्या किया, गामा इज इक्वल टू 0.1, 0.5, 0.7, और फिर रन किया तो फिर 0.1 आया. मतलब पहले 1 आया विच इज एक्सट्रीम साइड, फिर 0.1 आया ऑन द सेम साइड एक्सट्रीम, फिर मैंने इसको कम करना शुरू किया. तो इस हिसाब से आपको 2-3 ट्रायल एंड एरर करने पड़ेंगे फॉर ईच ऑफ द हाइपर पैरामीटर, तब कहीं जाके आपका हाइपर पैरामीटर सेट होगा.
Okay.
एनी अदर क्वेश्चन? नाउ आप लोगों ने देखा कि ये मेरे कंप्यूटर सिस्टम के ऊपर इट वाज टेकिंग लॉट ऑफ लोड. सो आइडियली सच प्रोग्राम यू शुड नॉट रन ऑन योर सिस्टम. गूगल हैज गिवन यू वेरी गुड फैसिलिटी कॉल्ड गूगल कोलैब, तो आप वहां पे जाके उसको रन कर सकते हैं. सो लेट अस एक्सप्लोर दैट पार्ट एज वेल. अभी ये वाला जो कोड हमने रन किया था वो पूरा का पूरा हम लोग रन करेंगे यूजिंग द गूगल कोलैब. दोस्त हु ऑलरेडी नो द गूगल कोलैब, बहुत सारी चीजें उनको रिपीटेड लगेंगी, लेकिन डेफिनेटली कुछ चीजें उनको नई जानने को भी मिलेंगी. सो लेट अस एक्सप्लोर द गूगल कोलैब. सो whenever I'm going to Google Colab, let me ठीक है, let me open new notebook. Okay, एंड वो जो स्टेप हमने वहां किए थे वो सारे स्टेप वन बाय वन हम यहाँ पे करते हैं. तो माय स्टेप नंबर 0 विल बी इंपोर्टिंग दिस थिंग. ओ, so here it will be importing appropriate libraries. That is my step number 0, then properly import हो गई. Then again I am adding my step number 1. It was my step number 1. My step number 1 was read data, right? So I'm now reading the data, and then to read data I need to have this. So let me run this, and you will see कि यहाँ पे error आ रही है मेरी. Again the same error, it is not able to find out our this CSV file, and you can upload. आप लोग क्या कर सकते हो, आप लोग यहाँ पे CSV फाइल को अपलोड कर सकते हो. तो कैसे हम लोग CSV फाइल को अपलोड करेंगे, लेट मी शो यू दैट एज वेल. So whenever I will run this code from Google Colab dot file import files and files dot upload, it will ask me that which file I want to upload. तो मुझे यहाँ से फाइल सिलेक्ट करनी पड़ेगी. फॉर एग्जाम्पल आई वॉन्ट टू अपलोड दिस प्राइमरी इंडियन फाइल्स. मैंने इसको यहाँ पे अपलोड कर दिया. फाइल मेरी अपलोड हो गई, प्रॉपरली अपलोड हो गई. फिर मुझे इसको रीड करना पड़ेगा, एंड रीड करने के लिए जो इंस्ट्रक्शंस हैं वो ये हैं. And with this, whenever I will run the code, okay, data files, नहीं सॉरी, यहाँ पे डेटा आएगा. इट इज नॉट डेटा फाइल्स, इट इज डेटा, क्योंकि ऊपर मैंने क्या लिया हुआ है, डेटा लिया हुआ है. तो प्रॉपरली फाइल अपलोड हो गई. नाउ द फाइल इज अपलोडेड इन द सेम फोल्डर. नाउ लेट मी रन दिस कोड. नाउ यू विल सी कि कोड मेरा सक्सेसफुली रन हो गया. एंड नाउ इफ आई प्रिंट, अगर मैं प्रिंट करके देखता हूँ, प्रिंट एक्स, कैपिटल एक्स, तो आई विल गेट द एंटायर डेटा. मेरा पूरा डेटा मुझे नीचे मिल जाएगा. मिल गया मुझे नीचे. सो माई फाइल इज अपलोडेड. दिस इज वन वे. हाँ, देन this is my step number 1 only. Now step number 2 will be split the data, split data into training and testing. So this is my second step, and let me write the code for this. So my code for this will be very simple. This one. Done. Step number 3 will be, here I have to find the best hyperparameters. Find best hyperparameters, and let me to have this, my code will look like this. And you will see कि इसको रन होने में भी टाइम लगता है. इट इज नॉट ऐसा कि तुरंत वो रन हो जाता है, बिकॉज इट इज अ वेरी कंप्यूटेशनली हैवी थिंग. इवन नाउ यू कैन ट्राई हियर. आप यहाँ पे एक और वैल्यू डाल दो, 0.01 एंड सो ऑन. डिग्री यू कैन रिमूव फ्रॉम हियर, दैट इज फाइन, क्योंकि डिग्री यहाँ पे नहीं आएगी. And now I will run again. See, it is taking a lot of time because it is computationally heavy. इसको इंटरप्ट करके फिर से करता हूँ. Okay, because I have done some changes, so that is the reason I am changing it. So this is my step number 3. Step number 3 हो रहा है, तब तक we will go for the step number 4. And in the step number 4, model fitting. And my model fitting code will look like this. The same thing what we have done earlier. हम वही चीज यहाँ पे कर रहे हैं. जस्ट वेट करते हैं, इसका में हाइपर पैरामीटर क्या मिलते हैं उसके हिसाब से हम इसको मॉडिफाई करेंगे. ओके, सो हाइपर पैरामीटर क्या मिले हमको यहाँ पे. My hyper parameter size c is equal to 0.5. Okay, so I need to change here my c value and my gamma value मुझे क्या मिली 0.1. तो मैं यहाँ पे चेंज कर रहा हूँ 0.01. लेट मी नाउ ट्रेन. तो ऊपर से जो भी हाइपर पैरामीटर आपको मिल रहे हैं वो हाइपर पैरामीटर के हिसाब से यू आर गोइंग टू डू सम चेंजेस हियर. यू विल फिट योर मॉडल अकॉर्डिंग टू दैट. तो आपका मॉडल यहाँ पे फिट हो गया. देन step number 6, last step. Step number 5, evaluation, model testing, and let me put that code as well, model testing wala code. And let me run this. You will see कि यहाँ पे I got the output as the my accuracy is 0.73, precision is 0.87, recall 0.76, and f1 is a 0.81. So by this way you can always run your code. Any question about this? इसमें से कोई doubt किसी को? Any of the step? इसको मैं सेव कर लेता हूँ मेरे ड्राइव में एंड आई विल शेयर दिस एंटायर फाइल टू दर्पण, सो दैट अगर बाद में भी किसी को रिफर करना हो तो कर सकते हैं वो. एनी क्वेश्चन अबाउट दिस? So there is one more trick, but I believe that we will cover it from later stage. Right now, what we are doing, we are executing everything in the Jupyter notebook. But there is a way you can access entire Python file, which you have stored in the drive directly in the Jupyter notebook, and you can run the entire Python file. So in that case, you need not to run this in a separate step. Entire Python file you can run. This is what actually I am doing. I am doing changes at my local system. Automatically it is uploaded to my drive, and I'm directly running my Python file through the Jupyter. But that we will see at some later stage. Any question, any query about this, and then we can conclude this.
So one of the basic question is there, like everyone asks that which is going to be one of the best IT firm in futuristic? Is it going to be ML, AI, IoT?
See, if you talk about the future, you have to define the duration as well. In the IT field, things are changing so fast, so dynamically, that it is very difficult to predict the technology which can rule over next 10 years. But for the shorter duration, till the time when you will pass, at least in next 2 to 3 years, at least machine learning, data science, and IoT, these three are going to be there, and they are going to be very well placed as well. And right now, we have a very uh, uh, what you can say scarcity of good programmers, good developers in all the three fields, maybe data science, machine learning, or the IoT. You select any of this depending on your interest, and just do the best thing in any of these three, and I can bet on you that job will be there, your development, your future will be there. There is no question about this. We cannot pick any of this one from any of these three. Reason is that these three are not competing technologies. If someone can ask me, sir, whether .NET will be there or Java will be there, I can at least give some hint. Reason is that because they are competing technologies, and one of them is supposed to be take a lead than the other. But these three are not competing technologies. Yesterday only I explained you that machine in an entire IoT cycle, if you talk about machine learning, IoT consists of sensors which will take input, actuators which will give output, and the processing can be done by the machine learning. So they are not competing technologies. They are not competitive technologies. They all are going to remain there. And in today's time, you will realize that data is increasing like anything. So you need to have a technology to process this data, and that is where even data science will also be there.
Okay, sir. And sir, one last thing I wanted to share with others and you also, that we had used one of the services, that is ML Studio provided by Microsoft. So it's a basically drag and drop, and in which we do not need to do any coding, and the coding is done by them in the backside. We have to just provide the data, and it's all about the drag and drop. So it helps in building our machine learning models.
For any of you have tried on that?
So basically, we did, like, we four were there. Harsh, me, Meg, and Maharshi were there in one of the hackathon, and we used and implemented that, and it was a good thing because it made us easily in not doing the coding and getting us the code, and we get a good accuracy in that also.
Um, then Darpan, if possible, we can have one separate session for that by either one of you or all four of you. Because honestly,
Sure, sir.
I am very much interested in knowing that part.
Okay, sir. We'll do, like, we will arrange something for that also. Okay.
Yeah, we
Even there is a sir, there is a HTML to JavaScript converter also online.
okay. But how it
But
is?
that also converts into CSS also. Some if you have something in CSS field. Sorry, CSS. If you have any type of text in CSS, it will also convert into CSS.
Okay, but how it is related to our machine learning?
Sir, it's not related. I was just sharing
Okay,
it.
okay, fine. No, actually, see, when we are in this session, so my entire concentration was on the machine learning. I'm sorry for that.
No worries, sir.
Okay. Um, and now we are deciding our next session will be by Darpan, Harsh, Meg, and who is the fourth one, Darpan?
Maharshi.
Maharshi. Yeah, I would like to hear something from the Maharshi. Yeah? So, and it is about this Microsoft tool for machine learning, right, Darpan?
Yes, sir.
Okay. Shall we sign off now if there is no more question?
Yeah, we can. Kavya, you can proceed.
Am I audible?
Yes, Kavya.
Yes.
So, good morning, everyone. I, Kavya, on behalf of Codebusters, extend a very hearty vote of thanks to Gaurav sir, who blessed us with his presence and took out his valuable time to make this webinar possible. You have been guiding us throughout. We can't thank you enough, sir. I'm sure that all the participants too must have learned a lot from you today. I extend a big thanks to the organizing team and volunteers for all their support and efforts towards this webinar. And I sincerely thank all the attendees for their cooperation and active participation throughout the webinar. We hope this webinar turned out to be very fruitful for you. Okay, now an important announcement for the participants. Only those who appear for the test will be receiving the certificate of completion for this webinar within 24 hours. And the test is scheduled from 2 to 3 p.m. IST. So please be ready and all the best. Once again, thank you everyone.
Just one last word, Kavya, Darpan, Harsh. I'm very much thankful to all of you, Priyanka, Maharshi, because you people are doing something which is not only unique, but this is very helpful to all the students, irrespective of college. They may be in any of the college, but when they are participating in such things, they are learning lot of the things. Thank you, and once again, congratulations to all of you. One last word. I'm going to share this PPT, this entire notebook and the Excel file, which I told you that I'm going to share that Excel file with you. And you have to apply machine learning concept on that particular Excel file. So after this session, I'm going to share these things with Darpan, and definitely either Darpan will email or the Darpan will put these files on our description section of the YouTube channel. It depends on the Darpan, but I'm going to share. And please, you try, you implement this support vector machine on this new data which I'm going to share you. Okay. So I'm signing off now. Chalo, bye everyone. Thank you everyone, and take care. Enjoy the remaining part of the Sunday. See you tomorrow.
Thank you, sir.
Okay.